Let's get started. Thanksgiving is an interesting time, particularly at schools. It used to be that, there was 2 days off, right? And then people started leaving town Wednesday night. And then so the Wednesday night classes basically got decimated. And now it's Tuesday nights. So one wonders when the university will decide that Thanksgiving is a week long. The problem is that we have a mandate for so many teaching days, and campus wants to be done before Christmas break, right? And so then you have to worry about, how do you schedule all those teaching days? You don't want to get pushed too farther in the summer, so it's always this. So any questions? Besides whether or not you need to use separate threads on the assignment or not? What? What do you mean by all at once? So the question is, should we have one observer that does everything or multiple observers that handle piece by piece, right? Is that, so the question is, how do we decide which one is better, right? When you got two routes you could take, how do we decide which one should be better, right? That's the question. Well, actually, your question is, you want me to tell you which one to do so you don't have to worry about it, right? Well, again, I mean, when you say both work, yes, both will work, right? Like I said in the beginning of this course, um, I didn't think that I thought all the students in the course would be able to make my assignments work, right? But the issue isn't whether they work or not, that is, they get the right output. The question is on the design part, right? And so then to answer your question, we have to ask, well, how do we, now we've got two possible designs, which one might be better? And so you have to ask yourself, what criteria can we use to decide whether or not design A is better than design B, or vice versa, right? And this is, once you stop doing toy assignments in universities and go to work, right? That's going to be it's always going to be the question to deal with, right? There's almost always multiple ways of getting something done in code, and so how do we decide A, B, or C, right? So how would you decide? So they're already suggesting one solution. You got lots of small things versus one big thing. Yeah, that's another decision you have to make, right? And again, you have to ask, I mean, you're going to make the program work either way, right? The question is which is a better design and why? You know, do you want a bunch of small pieces or one large piece? Um, we can talk about coupling and cohesion, right? We're going to ask which one would be easier to implement, which one would be easier to understand and maintain. Yeah, that's a problem with assignments, right? Is that, you know, particularly in this class, we're trying to get some practice doing patterns, um, and basically all assignments we had, we don't need any patterns, right, to make them work. And they're small enough that it's not going to matter much. So yeah, that is a problem with dealing with a basically fake context, right? And the only solution I know to that is, hey, well, I'll just in the beginning of the semester say, you're going to write this huge system, right? So get to work. Um, and actually, when I taught the client server course, when people took the same two classes the same semester, that worked out pretty good because then they're like, oh, they are writing a big system, right? And the other course learning about all these patterns they could use in that big system. But any other questions? What's that? Oh, the question is it fine to remove your password? It's required. I don't want to see your passwords. No, no, it could be any email address, right? It can be any email address. Yeah, yeah, fine. But I just, you know, if it's a real valid password that you use, I mean, I don't need to see it for the assignment, so there's no need. I mean, you exit out or something. Just well, we have two more patterns to talk about from the Gang of Four text. They're my two least favorite patterns. I'll postpone that until a little later. We'll see how far we get. Um, so I want to talk about dependency injection and solid. Um, so start with dependency injection, and I want to start with I'm copying Martin Fowler's example. And so he says, yeah, so the example is you want to write a program to allow us to search for all movies done by a particular director, right? And the context is you have all this movie data in a colon separated file. It could be a comma separated, it doesn't matter, right? It's in a file and you need to read it, right? And so he then creates a colon delimited movie finder class that reads a file and parses it and then stores the data in a way you can search it, right? And again, how it's stored and how it's parsed and stored doesn't matter. That's irrelevant. There's a class there where you go, here's the name of the file. It reads it and it does magic. And you say, give it a director and it'll spit back a list of all the movies they directed, right? And then, so it gets, a class called movie lister. And inside the movie lister, you instantiate this, colon delimited movie file finder. And then when you have this, simple method, movies directed by, and you pass in a name of a director, and then you actually ask the movie finder to say, give me the answer, and then we return it, right? It's a typical simplistic example, right? Illustrate a point, right? And the problem is, what happens when we decide, oh, wait, maybe it's not a good idea to use this colon separated file. Maybe we should put it into a regular database, right? Now what happens? Right? Now the problem is we have to go inside that movie class and change everything, right? And the real issue is that the dependency inside the movie lister class to a lower level service, right? And this happens all the time. I mean, we build up layers, right? We have little things that read the files, talk to the database, does this or that, and then we build on top of it, do something more complicated on top of that. And so we continually have our classes depend upon lower level services. And the problem is we often want to swap those low level services out with a new one, right? And it gets really interesting when it happens. Well, maybe we want to run this program locally, so it could be in a file, right? Or sometimes we want to run it elsewhere where we want to talk to a global database. So we may want to be able to swap them in or out, right? But to do this, I mean, we've got a problem because it's right. It's inside that class, right? Right. So we have this. That's interesting, right? We have these low-level services, right? And they build up and they build up. Like I said, we get this. Each class depends upon lower-level services, and when you want to swap them out, how do you deal with that? And so, okay, so the solution is programmed interface, right? So we'll create a movie finder interface, right? And we give it necessary methods, and then our movie lister, right, just knows about the interface, and then we can, somehow create an implementation, right? And then our movie lister becomes coupled to the interface and not the actual implementation. that helps, but now we want to be able to swap the implementation out, right? How do we do that? Wow, oh, there we go, right? One way is we can use factory method, right? And then we create a subclass, right? And the subclass, we just implement create finder a different way. So that's one way we can handle this problem, right? And then the subclasses, if you actually want to, talk to the database instead, there's a subclass that creates a database movie finder thing, right? And the rest of the code works. So that's one way of doing it. It does require us and then subclass for every different type of movie finder, we need a different subclass, right? But we could do that, right? And that's what the factory method is used for, right? It's like, oh, the subclass can return something different. Although in the Java world, you have to have an interface so that, right, it returns something the same super type. Yeah, so for each concrete finder, we need a concrete subclass, and it just, it's not that hard. You just have to override that one method, and then we're good to go, right? And then you just have to know, do I create the parent class or one of the subclasses? And maybe you have an abstract parent class, and then they're all, all the subclasses are just the actual concrete ones you want to use. Another way we can do this is just use a constructor, right? You just pass it in. You say, oh, here it is. Here is your movie finder that you want to use, right? And then when you instantiate it, you have to say, oh, I want that movie finder or this movie finder, which actually just, in both cases, we've pushed the problem elsewhere, right? This solution, someplace you have to say, create new, new something, something, something equals this, and then you pass it in this constructor. And in the factory method, at some point you have to say new movie lister subclass, right? This one or that one. So we make it possible, but the actual decision is going somewhere else. Decision isn't big, right? It's maybe one line, but the problem with pushing it somewhere else is that if this is the only place in a program where you do it, it's no problem. But if there's 5 or 6 places like this, we want to be able to swap things out. And then it's like this and this and this, and it gets not quite as nice, right? And so here, for each concrete finder, we need to get the class. But that's okay, but the actual core itself is not dependent upon the concrete class. And so then doing this, we get sort of manual injection, right? We create the movie finder class and we just put in the constructor. And it's sort of odd that there is this fancy sounding word for just passing in an object in a constructor. Like we do it all the time, right? With constructors, that's what it's for. And you have arguments. We've got methods, we put arguments in, and now it's injection. Yeah. But the idea is, right, that we have this class that depends upon lower level services. And now we're going to add that service to it externally. And so once you understand, oh, we're like, it's like injecting it in, right? So they call it injection, right? Right, except they push it further than this, right? Um, so this is, this is manual injection or constructor injection, right? And it's, right, instead of, we started with movie lister, then directed by, now we get create the finder, inject it in, and then, right? Slightly more complicated, but it gives us flexibility, right? And the problem is the scaling is hard, right? If you've got one or two of these, no problem. If you have 10 of them in different spots in the code, it's like, oh no, now we have to, it's just, right? You might need the same injection in different places and different injectors in different places, um, right? And the program is still dependent upon the dependencies, right? So we can come to another pattern, right? I assume you're all familiar with plugins. If you ever use Eclipse, you always add plugins, right? Um, and basically, what does a plugin do for you? It's something you add later to the program that adds functionality to the program, right? And so the key part is the program is compiled and generated, and then later we're adding functionality to it, right? It's not a compile time addition, it's a runtime addition. And how do you do that? Yeah, but what does that do for you? How does it actually work, right? I've written a program over here, it's compiled, I gave it to him, and then he can write something to add functionality to his implementation, but he doesn't have the source code. He doesn't have the source code. And it's not recompiled, right? So yes, we need a configuration file, but how do we do that, right? In Java, we have reflection. That is, I can take the name of a class in a string, and then I can basically load that class at runtime, as long as that class is in the class path of the program, right? So the way Eclipse works is, yeah, there's a directory you always put the plugins in, and that directory is in the class path, right? Right? And since Eclipse is written in Java, you can then load that class at runtime. All you need to know is the name of the class, right? And that's where your configuration file comes in, right? It's like, okay, here is the name of the class we want, and then we can read that and then do class for, and then get an instance of that class, right? And yeah, it links classes during configuration rather than compile time. And then you usually have some configuration file to tell you how it all works, right? So what do? You have to find an interface that those classes are going to implement, right? So okay, here's the interface. Here's our movie finder interface, right? And then he can implement all the classes you want that implements that interface, right? And the interface is separate from his code, right? That interface is with a package that we compile into our program. So our program knows about that interface. And then at runtime, we'll read a configuration file and say, oh, right, here's the concrete name of his class, implements that interface. I can then load it at runtime and then pass it around to where it needs to be in my code. And I could treat it just like that as that interface, right?
Which instantiate code is still so instantiate program is still running, switched out.
Yeah, I mean, basically at runtime, I'm going to read your class, right? And create an instance of that class. And then I can use that. It's an object, right? That implements that interface. So wherever I have that, a type declared that interface or a parameter of that interface, I can now pass in your instance of your class, right? And that's basically how plugins work, right? And then of course, I need a place where I can, give me the object, right? So yeah, we can use a factory, um, you know, and then we need a configuration file, right? Well, we have to read the file to figure out what classes are available. Um, right, and so yeah, the plugin reads the class of file you need, right? And then this plugin factory will create it for us. Um, and his code is completely separate from my code, right? Yeah, yep. We'll get to that in a minute. Any questions so far? Now, one thing that sort of hides is um, in the movie finder example, if you've got 3 or 4 concrete implementations, the question is how do we determine which one to use at runtime, right? So it may have to be some criteria, or the user selects which one, but there's a choice. If there's more than one implementation of my interface, right? He produces one, you produce one, and she produces one, and we've got 3 of them. We add them to plugins. How do we decide at runtime which one to use to satisfy that feature, right? So that's a problem that Eclipse has because people. I mean, if you ever look in your plugin directory of Eclipse, this goes on forever, right? There's like thousands of them, and if you don't have reflection, it gets harder, right? Because then, how do you? Um, we really want 2 things: reflection and be able to load classes at runtime, make things easy for a plugin. Python also has their Python path, right? And so anything that's in your Python path, you can instantiate, right? So in Python, you can do this. Swift is a bit more interesting. And in Java, how do you load classes at runtime? Class or name, right? And you give it the full name of it. That will look for that class on your class path And when it finds it, it will then, if it's not loaded already, it's going to load it at runtime and then instantiate it and give you the class, and then you can call a constructor on it or whatever you want. Right. So what does that have to do with dependency injection? There are small little frameworks that do dependency injection for you, and they use a plugin pattern. Yeah, there's always different term. I mean, if injection isn't fancy enough for you, you can use other terms and have arguments as to what term is better. And yet, they talk about different types of dependency injection. One is constructor, where it's passing the constructor, setter, when passing a setter, interface is a bit more complicated. I mean, your class has, there's this interface that I want this thing to implement, and it will. So there's a number of different frameworks which will do dependency injection for you. Pico container is one, Spring is another, but there's a whole bunch of them, and I'm not even sure Pico container still runs, but it was a small so we have a movie lister class, and it has this constructor which requires a movie finder, and then we've got this calling limited movie finder, which implements the movie finder interface, right? It does a bunch of stuff. And then for Pico container, we have this, whoops, we get this Pico container, we get a default one. Oh, my constructor needs an argument, so we need a list of parameters. And so again, we're using reflection, so it can't be a string, and so they got a constant parameter. There it is. And now we're going to register. Okay. If you ever need a movie finder class, then you're going to use this class to replace it. And when you create this class, you're going to pass in those parameters. And then you add in the movie lister class as one that we want to do injection on. And what does this do for us? Basically, it says now when we want to create a movie lister, Pico container is going to say, movie lister is limited component, so I need to look at a constructor. The constructor needs a movie finder. How do I create a movie finder? There it is. It says I need a movie finder class. Actually, replace it with this one and use those arguments. And so now, I can now tell a Pico container to give me a movie lister instance, and it will then look at the constructor and say, it needs a movie finder class, and you told me to use a movie finder. I use this other class and create that with that argument. And so I just say, this is telling what we need. Just one needs the injection, and then to actually use it, we call our configure container and get component of movie lister, and it does this magic to inject in what we want, and then we're good to go. And this allows you to, if I need movie finders in different spots in my code. It's all taken care of. If I want to change it to a database movie finder, I just configure the one spot in the Pico container code where it says what to use. I have multiple spots to deal with, right? Of different injections. We just configure it. So we've got one configuration spot where we say, here's the class that needs to be used in this situation. So we started with that, right? Now we get this. But again, it's like the patterns, right? The patterns make your code more complicated, right?
My experience in this is pretty limited. How often would you say source code major applications does source code in major applications change enough to be usable, or is it like very?
Yeah, it's pretty much case by case, right? I mean, Eclipse has a very strong use case, right? I mean, anytime you have there's IDE that you want to be extendable, right? And you want other people to help you extend it, right? So you want some sort of plug-in system where they can somehow add functionality to your IDE. And then, okay, here we go, right? So anytime, we want to build a system that we want other people to help extend and don't necessarily want them to recompile everything, right? Then we get this. Yeah, I mean, every time we use a pattern, right, our code gets more complicated. It gives us certain types of flexibility, right? But once you start using too many patterns, it gets too flexible and the overhead becomes too much, right? And already, I mean, like you said, I mean, I basically took 2 lines and now it's the whole, almost takes the whole slide. And you bring up the example of Spring. It's used all the time in Spring, right? I mean, it's the only way you do it is you create this huge, you got this XML file and you read it in, you got this whole thing to configure how your things fit together. And again, the problem there is you're building a system to try and provide optimal flexibility to other developers, right? And then, of course, there was this huge reaction against Spring-like systems, and Java been huge, so then you get Ruby on Rails. I don't know, just we're gonna simplify and make it easier for people, and different other frameworks come along and say, Java became too large, too complex, too monolithic, and those other systems then again have the same problem. It's like, okay, now as Ruby on Rails ages, right? You say, well, we need more use cases. Like we do it for the main case, but then people start using it like, oh, it's great for its main use case, but once you get off that, it's hard, so you want to extend it. And yeah, file. In Spring, it uses not constructor injection, but it uses setter injection, right? So you need a setter for each thing you want to inject into it. And then you get to build an XML file, which explains what to inject where and when, right? And then you have to read that file and you have to understand how all the pieces work fit together. But again, going back to the beginning, right? Oh, if we want to handle multiple cases, we can just use a factory method, right? And that's a lot easier than using Spring. A lot easier, right? But the problem becomes if when your software gets big and you need 10 different spots where we need these subclasses to handle various cases, and that becomes hard to manage just using abstract factory or a factory method. And then you can, instead of you can use a factory method maybe, right? Or abstract factory, because now you can say, okay, here's one factory which has one combination of all the different things you want to inject, right? And then if we want to do a different one, we'll use a different abstract factory for a different configuration set, right? Yeah, so the interface injection becomes even more complicated because you create an interface for how you want to interject the thing into the system, and then you have to input that interface. But it makes it easier to do the injection automatically because now you have an interface to program to, as opposed to trying to find the setter, right? But and then once you have a bunch of different injections, like I said, you can combine it into a single service, right? Service locator, and then it knows all the different pieces you might want to use, right, to inject into various spots. And so you ask it to give me a movie finder, and then once I got that movie finder, I can put it in all the right spots. And if I have other things I need to inject, right? Are you talking about what happens if our movie finder has a self-dependency? Um, yeah, that gets more complicated, right? Because now we need to first just configure our movie finder, and then we can use that object inside of another one. Yeah, you'd want the service locator to be able to handle all those cases. And then it gets more complicated, right? Because when you start But it does give us, right, we can go from, oh, just don't worry about dependencies, right? Or we can use the factory method, right, to break it out. Then we can do manual injection. And that gets not good enough. We're going to go to a more complicated system. So it gives you a whole range, right, depending on what your needs are. Do you want to start with Spring? Not likely, right? Yeah, and that service locator needs to be, probably a singleton, right? Because you don't know where you need to find it, right? And then it's probably an abstract factory, right? Because you're going to say, give me this, give me that, give me that, give me this. Um, and yeah, you can create one either in code or you can have a file which reads it in and figures out how to configure it. And so yeah, we can do it different ways. Perhaps I haven't thought about it, but yeah, I mean, you basically say, give me this class, right? And well, but that's just basically, a class name for, and then you give it the name of the class and it looks in your class path for that particular instance. A number of years ago, dependency injection was a big buzzword, right? And people built all these injection frameworks, and it's still used. I mean, right? I mean, you've had the pleasure of using Spring, right? So far, so good. A relief from patterns. Um, there is this acronym called SOLID, which you'll find in literature. Again, it's an abbreviation for different types of things. So the S stands for the single responsibility principle. O is the open close principle. The Liskov substitution principle is the L. Interface segregation principle is the I. And the D is dependency inversion principle. And it was, I think, first formulated by Uncle Bob, as he likes to be called. Um, he was he became famous in C++ world. He wrote a lot of C++ books and was a high-powered consultant. And then he sort of graduated to more OO arena and became a player there. And he still writes books. Currently he's pushing Clojure as opposed. So he went from starting C++ and has gone all the way over to the other side and with Clojure. He is a very entertaining speaker. So if you ever have a chance to hear him talk, it's worth your time. He has a number of YouTube videos he now has. Yeah, there's several books out now on, designing and software development. And so he had, what's that? Clean Code is one of his books, right? And I believe the series of videos he did, he dresses up as a starship commander in the Star Wars, and then he has this fake commander chair, and like I said, he's an interesting speaker. Yes. Um, right. Yeah. Yeah. Those videos. I think it's a bit over the top, but some of those talks, he'll start off with sort of a weird topic, and then that leads into serious, really try to challenge people's ideas on. So single responsibility principle is a class should only have one reason to change, right? And so it's a different way of saying it should only do one thing. It should only have one reason to change, right? And whatever that reason to change is, that's his responsibility. And he says this is, of the solid principles, this is the simplest one, but it's the hardest one to do right. Because what does it mean? What's his reason to change, right? Now he gives this example of a modem example. The example is clearly dated because some of you have probably never used a modem, probably never seen one, right? Never heard the famous tones it makes when you dial up and try and connect. What's that? Yeah, that's um so he says, here's sort of a again a toy example where you have this modem, and what do you need to do? Well, you need to dial, right? And hang up, and you also need to send and receive information. We talked about, well, but that's really two separate types of operations, right? Dialing and hanging up are one thing, but sending and receiving are different things, right? And if a new protocol comes along, how you want to talk and send and receive, we're going to have to, the send and receive methods will have to change, right? Because now when you go from one protocol to another protocol, dialing is still just talking to the phone system, right? You send the tone, and that's dialing, right? Hanging up is just dropping the connection. Whereas the send and receive, right? So those two things could change depending upon different things changing, right? So he says, um, this implementation does not satisfy the single responsibility, right? If I want to change from a dial-up modem to a cable modem, well, you don't dial up, right? And so the dialing, hanging up, right, will change depending on some circumstances. The send and receive can change in different circumstances. So he says, yeah, there's two reasons to change, and they're distinct. So it doesn't satisfy the single responsibility principle. All right? And then to make your life miserable, he says this, right? if you can always slice and dice in different ways. Well, this might happen, but if it never happens, then it doesn't matter. Right. So then it gets this sort of implementation. It divides into two pieces, right? The making the connection and then transmitting and receiving data. Right. So yeah, it's like implementation. Keep them in the same class, but define interfaces, right? No one outside the class has to know about it because they either worry about the sending and receiving interface or the starting and stopping the connection interface. The open-close principle, he's not the one that formulated the open-close principle. That came from the creator of IFOL. Basically said, yeah, we want a class to be open and closed. Closed for modification, but open for extension. Right, and that's what it says. You should be able to extend a class without modifying its behavior, or modifying it, right? So it's basically the idea of, well, we know several ways of doing that now, right? We can subclass it. We can use the adapter pattern. We can use the wrapper, the wrapper, right? So now several ways of actually doing that, right? And
Extensions implement.
extensions meaning, yeah, you can think of extensions are another way of adding functionality without changing the class, right? What does modifying the class mean? Right. So we can actually change the interface of the class. But you don't need the source code to do that. So it's a strange mixture of, yeah. But in practice, I find that, well, there's a direct way of doing things, right? And then, sometimes the direct way is sort of hard to do. So I start using patterns to do things, right? And that becomes more complicated. Why do we need this pattern or this principle? The problem is once you modify the class, that modification now propagates out to the rest of the program, right? In Java, if I modify the class, I have to recompile the class, and if it changes the interface, then we have to then recompile all the classes that use it, right? And the greater the changes we make to that class, the greater the chance those things will propagate into other classes, and they have to be modified and recompiled, and modified and recompiled, right? So what we're saying here is, look, once you got this thing in production, people depend upon this class to do, behave this way and have this interface. If we want to change that, now we have to go find all the places that are coupled to it and then see how that affects those, right? But if we can extend it without doing that, then we can add more features or functionality or ways of operating, and we need to do that because most of the time there's version 2 of the software and 2.1 and 2.4 and 3 and right and on and on. And over time, you find more use cases or what we thought was important is not quite important, and this becomes more important. And so we have to adapt our software to varying conditions.
Does not provide the source code. And then classes are not the chain.
Right. You add more features to it, so you can actually code can still use the base class as the way it was defined, right? And then we can add more code that deals with extended pieces. And we don't have to worry about creating subclasses and injecting those into the system, right? The Liskov substitution principle. The Liskov in question is Barbara Liskov, so it's a female. She was a professor at MIT. If you're professor at MIT, you're clearly very good, and she was extremely good. And, she did a lot of early work in the old world, and this is one of her principles, and it's subtle, right? You know, child classes must be substitutable for the parent classes.
Performing the same functions, the same.
What she means is I've got a program and I'll get a parent and a child, right? Wherever I have the parent being used, I should be able to take a child and use it there.
And get the same.
Not necessarily the same output, it should be usable, right?
Okay,
Usable.
that makes sense. Usually functionality or extended.
Yeah, but this is subtle. And so an example to illustrate this is a stupid, crazy example you see in every book, which is just ridiculous, right? That a square is a subclass of rectangle. Right, and so we got this rectangle, right, and you have a width and height, and we can do all the setters and getters you want, and then to create the area, so height times width, right? And then I can create my square, and then, well, of course, to be a square, the width and height to be the same, right? And so the constructor, and then when we set the height, and we do the same thing with set width, right? And the square is, and then you do something like this, and it's like, what? That's weird. I mean, it's like, no, I mean, this violates, people are not going to accept that, right? It's not correct. But if I pass in a square object, that's what I get, right? Why? Because when I set the height, I call super width and super height. Because the square has to maintain the same. So the problem is this example, right? We can't really substitute a square where a rectangle works because the behavior is changed too much, right? Anyone who reads that code can say, "Oh, that's wrong," right? You set the width and the height, and so the area should be 10, right? And so what the principal is trying to avoid is exactly this, right? Because anytime we have a child class, we should be able to instantiate it and pass it along to wherever the parent get accepted, or right. But in this case, we get behavior which we do not like, right? It's like, oh no, it's not what should happen. Right? And so the Liskov, right, principle really constricts what your subclasses should be able to do. Well, because I could pass in a square object, right? Right. And so the problem is the behavior of the square is significantly different than the rectangle, right?
So is the idea behind this principle that it's supposed to govern distance between the abstract, between the parent and the child? The idea being that you're not supposed to create a child class for too dissimilar. It's just supposed to be like the original. Like you go from square to sphere.
Yeah, it like I said, it confines what the child classes should be doing.
Is there like some principle there? I'm getting at. Like how did she arrive at the question?
What's that? Right, yeah. And you shouldn't, weird things shouldn't happen, right? It should.
Oh, this is just a principle.
Right, yeah, yeah. Right? So why should a square be a subclass of a rectangle? Follows what? Yeah, but it doesn't really work this well, right? What about parallelogram?
Isn't definitions of that for writing?
But it's just,
It's a four-sided polygon, yeah.
it's a four-sided polygon, and it's an area, and we compute the area of the height and width, and we form this. So
Class square. Width is all you area. Height.
but then you get the problem of when you equate a variable of type square, you don't know just how to set length, right? And then when I put a rectangle in, I can't set width and height. Yeah, so that's, yeah, I mean, people do this, right? You see it in the books all the time, and it's like, just forget it. I mean, don't use these silly examples, right? And you know, Have you ever seen in real life when you've got geometry they do this? No, they don't do this, right?
My experience, like shapes at all.
No, right.
And like a
There's-
rectangle's a rectangle, and that's over here, and a square's over here. And
Right.
Just don't,
They don't mix, right?
they're
Yeah.
just separate.
I agree. And then, so why, I mean, and you see this example all the time. It's like, no, don't, I mean, just, um, you know, what they're saying, yeah, I mean, the behavior is different between a square and a rectangle, right? And subclassing is about behavior, right? It's not about, oh, the structure is almost the same. We talk about the structure, not the behavior, right? It's all about behavior. In general, people really like to use inheritance, but it's probably overused.
Just like media interface, or what?
Well, again, is this sort of the simplified test that people use to determine whether you should subclass or use composition, right? And so, if A is a B, then A should be a subclass of.
Super thing.
Right, but then you say a square is a type of a rectangle, right? But what they're saying is when you say that word, that phrase, you have to think about the behavior, right? Does a square have the behavior of a rectangle? Not really. So we got two more, right? We got the I and the D, and I think we'll cover them next week. I assume I don't tell people that there's no classes on Thursday.